Okay, so today I'm gonna continue chapter 3. Let's first make very quick revision on what I did in chapter 3. Yeah, so actually there are three main laws we are going to use all the time. They are very important. So the first one here, as I explained in chapter 2 and 3, Ohm's law. Okay, and very simple. So what happens here, if you have a resistance this way, if this terminal is positive, this terminal is negative, and the current is flowing this way, and you have a resistance here R. So Ohm's law is telling me, and you have here, this is the current I, the voltage drop here is V. Voltage drop, the difference between this voltage and this voltage, okay, is V. So with the Ohm's law, V should equal I times R. Is that okay? So if I know the resistance and I know the current, for example, I can calculate the voltage across the resistance. Or if I know V, if I know R, I can get R. Okay. So anyone missing, if you know two unknowns and you can get the third one, is that okay? One more thing I told you also. 1 over R, we call it G, or conductance. It's possible that in a question, I give you the conductance instead of R. So very easy. You got what I'm saying? So if I give you G, you have to flip it to get R. So R should equal 1 over G. That's it, very simple. Okay. This is the first one, this is Ohm's law. That's what I taught before. Number 2, also, I explained Kirchhoff current law. Okay, and what I explained here is for any node. So, for example, if you have here, okay, we have a node here, node. Okay, hopefully you are not confused about what I mean by node. Any connection is a node. So all of this is just one node, and any point here in this node has the same voltage. So anyway, so this is one node. If you have current here enter the node, I'm going to call it I1, and I have current output here I2, and this one is output I3. It's very simple. So summation of the current in, this is true for any node, should equal the summation of the current out. Okay. In this case, I1, which is in, should equal to out, which is I2 plus I3. Okay. And by intuition, this should be true because current is related to the amount of charges. So if you have some charges, if you have a certain amount of charges coming this way, these charges are going to be split. Some of them go this way, some of them go this way. But the summation should be the same because they are not going to vanish. They are not going to vanish. You got what I'm saying? They are not going to disappear. So the same, that's why the same total amount of current here equal to this current plus this current. Any questions? Okay. The third one I explained also last time. Kirchhoff voltage law. Okay. And this one should work this way. For example, if you have this one work on a loop. So this one is a loop this way as you see here. Okay. So the summation of the voltage in any loop should equal to 0. Okay, but how we're going to do this one? That's what I will tell you. That's what I'm going to explain now. Okay, so the summation of the voltage in any loop. So this is one loop. Okay, so here I'm going to assume the direction is this way. Okay, so here this is you have here I1. It's by the way, it's the same I. So here also it's the same I. Okay. This one I'm gonna call it R1, R2. So the V1 we have here, the voltage drop is V1. The voltage drop here is V2. This is positive. This is negative. Positive, negative. Okay. So here, if I'm gonna assume the direction is this way. Okay. So you can see the direction is similar to I here. So V1 should be positive, V2 also should be positive, Let's make it easy. So now in this loop you have Vs, you have voltage here, you have voltage here, you have voltage here. So summation should be 0. Is that okay? But look at the polarity. Okay, so this is number 1. So number 1, this voltage plus this voltage plus this voltage should be 0. Okay, so how I can decide the polarity? Okay, so here I'm gonna assume this is the direction. Okay, so because this one is the same like this I, so this one positive. It's the same one, it's the same direction like this I. It is positive. If it is in positive direction, it will be negative polarity. Okay, here for this one, if this direction enter or is actually encounters the negative first, this one is negative. If it encounters the positive first, it is positive. Okay, so let's look at this case. So in this case, V1 plus V2 minus Vs is equal to 0. Okay. Someone can ask me, okay, can you do it if you change? You told us it doesn't matter if you change the direction. Yes, I can. So for example, let's do the other direction this way. I'm going to change the direction. So as you see here, because the direction is the opposite of this one, and the opposite of this one should be negative V1, negative V2. Is that okay? Because it's opposite direction. And this one is countering the positive first, so this one should be positive plus Vs is equal to 0. You can see it's the same equation. Okay, so this is true for any loop. Any questions? Okay, so these very important laws, we are going to use them all the time. So last time I explained several examples. So I explained this example. I applied Ohm's law, Kirchhoff current law, and Kirchhoff voltage law. And you know what I did here? I analyzed the circuit. So what do you mean by analyze the circuit? It means I need to find all the voltage and the current of each element. So I have to find everywhere voltage and current. So some voltages here and currents are given to me. So given the information I have, that's how it is. You have to think this way. What information I have and how the real laws can help me to find the missing. So what is missing here? I give you V1. V1 is the voltage here. This is given to you. Do I give you I1? This I1? I1 is not given, so I need to find it. Okay, so I need to find I and V everywhere here. Okay, so this one is giving you V1, I3 is giving to you. Okay, nothing else is given to you here. For sure, the values of the resistors are given to you, but IS2 is not giving. The voltage here V3 is not giving. V2 you have to find it. Vs you have to find it as well. Okay, so I explained this one last time. I already explained this to example, and I stopped here, so I'm gonna explain this one today. Okay. So I give you this circuit here, as you see. We have here a battery, voltage source. This one is 12 volt. Yeah, we have two resistors this way, this resistor this way, and then I have another battery here, which is 8 volt. This is a circuit given to me. Okay. So, and then I need to find everything else. I need to find the current, the voltage everywhere here in the circuit. Okay. So what I can do here, I'm going to assume the current here I1 is in this way. I1 is this way here, coming this way. So this I1 here, the same current here, I'm going to call it I1. It's going to come here and come here. Okay, so I'm going to assume this direction. As I told you, you can assume the other direction. It's not going to make a difference. That's what I want you to, as a practice. When you go home, you can change the direction of the current and you see what's going to happen. Because I told you here, I'm assuming I1 is this way. This is just assumption. Okay, or choice. I choose it this way. Okay. After I choose this way, when I calculate I1, if it is positive, that means it is true in this direction. You get what I'm saying? If it is negative, that means no, it should be in the other direction. Okay. So anyway, so this is just a choice. I choose it to be this way. You can, when you go home, try to select other direction. You should get the same results. Here, I'm assuming the current, there is a current coming here, going this way. It's not this way. It's this way. Again, just a choice. Okay. You can assume this way, no problem as I told you. Same thing here, we have I3. So here, what you need, what you should know here is the current here in this branch, always it's the same current because these two are series. So the current flowing here is the same current coming here. So this one I3 here, so this also I3. Okay. So again, all what I'm gonna do, guys, as I told you, using Kirchhoff current law, Kirchhoff voltage law, and also Ohm's law, and the information I have here. Okay, so I will try to get everything in the circuit. Okay, so let's see how we can do. The first thing that's very easy we can apply now is actually Kirchhoff current law. You can see here I1, and you have one node here. This node here can give me a because this is the main thing, guys. Using these three laws, we try to get some relation, some equation, and then using these equations, we can solve them to find the unknowns. This is the main point here. So the first relation I can get here is actually a relation between I1, I2, and I3. Okay, from this node here. Okay, so here in this node, this current I1 is entering this node. I3 is getting out of this node. I2 is input the node here. So 2 input and 1 out. So this is very easy thing I can do. So this is the first equation, Kirchhoff, the first equation here. I can say here I1 enter plus I2 enter equal to I3 out. Is that okay? Very easy. And even in exams, even if you can solve, even if you can solve this equation, if you can just do these steps, I'm gonna assign some marks for each step. Okay, so it's a very easy thing to do. Someone can ask me, okay, why you don't take this node here? Is this a node? Yes, this is a node, but it's not gonna help me because I'm not gonna get a relation of anything because this is I1 and this is I1. You got what I'm saying? So this is not gonna give me this. The main point here, guys. I selected this node because this one gives me a relation between I1, I2, and I3. Can I take this node? Yeah, you can take it, but it's not going to help you because is this node actually, if you take it, I3 input, I3 output. So I3 is equal to I3. It's not going to help you with anything. You got what I'm saying? Anyway, any questions? So this is the first thing I did. I found the relation here between I1 and I2, I3. This is the first relation here. Number two, I can apply this. We have one loop here. We have another loop here. One loop here and another loop here. Okay. So if I apply Kirchhoff voltage law here, I'm gonna get an equation. If I apply Kirchhoff voltage here, I'm gonna get another equation. Is that okay? So that's what I'm gonna do right now. Let's see how can we apply Kirchhoff voltage law here. Again, as I told you, I'm gonna assume this is the direction. The direction is this way. Okay. I think in most of these examples, we assume the direction are this is clockwise, right? So clockwise. Again, you can assume any other direction, but anyway, I think in this example, we always assume it clockwise, but it's not a big deal as I told you before. Okay. So anyway, let's see how can we apply Kirchhoff voltage law here and also here. Okay. Let's see. So again, Kirchhoff voltage law is very easy. We have a voltage here, we have voltage here, we have voltage here. Summation is equal to 0. But now look at the polarity. Okay, so now we have this voltage plus this voltage drop here plus the voltage drop here is equal to 0. But you need to look at the polarity. Okay, or the sign. So let's start here. See, this one here is enter to negative. So I told you the direction here is encounter the negative before the positive. So as you see here, the arrow here is gonna encounter the negative before the positive. This one is negative. That's why you can see in this equation I put negative 12. Okay. Number two, if here I assume the current here is going to be this way and the same current, so the current will be this way. It is in the same direction of this loop here, the same direction. So here, this one is this way, and also the current is this way. So this one becomes positive. So this one actually 2 times I1, because this is I1, this is I1. So it's going to be positive 2 I1. Is that okay? Let's look at the third one here. In the third one, what is the amount of voltage? It's 8 times I2. Okay, V times I times R gives you V. Okay, so the voltage drop here is actually 8 times I. Okay, is that positive or negative? In this case, it has to be negative. Why? Because I assume the current is this way, but actually here in this one I assume it's this way, so they are in opposite direction. So this one should be negative. By this way, I was able to get a second equation this way from this loop. Okay, if you didn't understand it well, I'm gonna repeat it again, but for this loop here, because it's almost the same thing. I will apply it here, okay, to get another equation. Okay, so when I apply it here again, very simple. The voltage here plus the voltage here plus the voltage here is equal to 0, but we need to look at polarity. Okay, this one here, as you see here, the direction of this loop here is encountering the negative first. The positive first. That's why this one should be positive. That's why I added here positive. Okay. Now look at what is the voltage here? What is the voltage across this one? Very simple. This one I3. So it's going to be the same current here. Here I3 and this one I3. Okay. The current here is going to be I2. Okay. It's not the same current like this one because these two are series. So the current coming here. The current is going to be split here, split at this point. So for example, if the current comes this way, okay, it's going to split at this point, this way and this way, okay? But this current here is the same, like this one, because they are series. There is no branch, here. So whatever comes here, it has to go this way, okay? Anyway, so the voltage here is actually I, which is I3, because I3 here is the same current here is I3. I times 4. Okay, the voltage here is 8 times I. V is equal to IR on slope. Okay. Now let's look at the polarity. Very easy. Polarity is this one here. Okay. So the direction here is this way. If you look at the direction here, this one is this way, and the current is this way. So it is positive. So as you see here, this one is positive. Let's look at this one. It's up this way, and the direction here is going to be also up in the same direction of this current. Okay, that's why also it is positive. Any questions? So all what I did, guys, very simple. All what I did, I applied Ohm's law, I applied Kirchhoff current to Kirchhoff voltage law in order to get 3 equations. And in these 3 equations, I have 3 unknowns, which are the current I1, I2, I3. Is that okay? I have 3 equations, they have 3 unknowns, I1, I2, and I3. Okay. If I can get I1, I2, I3, it's very easy to calculate the voltage here, and then I am done. I found everything. You got what I'm saying? So if I can find the 3 currents here, I can easily calculate the voltage here, using Ohm's law. Okay. So anyway, so now, and this is the fun, this is the interesting part. So now I need to solve this. You know, if you have 3 equations, if you have 3 unknowns, if at least you need 3 equations. Okay, 3 equations should be enough to solve to find the 3 unknowns. Okay, so the way we can solve it. So I'm gonna rearrange this equation to make it in matrix. Okay, so as you see here, the way I'm gonna rearrange it is always the first one should be I1, always the second term should be I2. Okay, so even here we don't have I1, so I'm gonna put 0 as you see here. So always let's look at the first one here. So I need to rearrange it just to make it in a matrix format, as you will see here. I have to start with I1. So this one only has I1 here. So I'm going to put I1 and it's multiplied by 1. Okay. Here, this one starts with I1, so I have this one, I have no problem. This one does not have I1. Actually, so I can say 0 times I1. Okay? So I need to have all of them because these numbers are going to be here, 1, 2, 0 should be this column in the matrix. Okay? Let's see I2. Here we have here I2 multiplied by 1, I2 multiplied by -8, as you see here, I2 multiplied by 8. So 1, 8, oh, sorry, 1, -8, and 8 is going to be the second column here. So these are the parameters of I1 in the 3 equation. These are the 3 parameters of I2 in the 3 equation or coefficients. These are the 3 coefficients of I3 in the 3 equation. Okay, and this is the result in 0, 12, -8. So I just again, this is just a very easy way. If you have 3 equations, 3 unknowns, so I can use matrices to solve them. Okay. So now let's I3. So this one already has I3, but I have to move it here. So it should be -1 I3. Okay. This one does not have I3, and also I have so the constant number here has to be. I have to move it to here. Okay, as you see. So this one 0 I3. So I have to rearrange. We have to reach the equation to be in this format, as you see. Okay. So then I'm gonna make a matrix that has the coefficient of I1, I2, I3 multiplied by I1, I2, I3, and this is the result. Okay. So and then in order to get I1, I2, I3, so I need to calculate the inverse of this matrix. So actually I1, I2, I3, I need to calculate the inverse of this matrix, and then I have to multiply it by this matrix, and then this is the result I will get. So once you get this result, so actually I1 is equal to this number, I2 is equal to second one, I3 should equal to the third one. Okay? In quizzes, okay? I hate because the main point here, is how to get equations. This is the main point. How can you get the equations, okay? I hate to spend too much time on, it doesn't make sense just to spend 5 minutes to get equation and then you spend 15 minutes to solve the equation, okay? Because the most important part here is how to get the equation for me. So in exams, in anything, most of the grade or most of the points will be assigned to getting equations. I will allow you to use calculator. If you have, you should, I'm not sure if you already have a calculator that can calculate the inverse of matrices, multiplication of matrices to help you or not. How many students here has calculator? You don't need to make matrices. If you can solve it in any way using calculators, I will be okay. You need to solve it in any way. You get what I'm saying? But if you have a calculator that can get the inverse and the multiplication of matrices, okay, thanks. So that you can use it. Okay. Have you done this before, or this would be new for you? You did it before? Okay. Okay. Because I don't want to spend too much time on something that's not the main focus. The main focus here is actually, or the main point, how to get equations. Okay. If you just, this is what I'm teaching in this course. Once you get equation, it should be easy to calculate. You have to find a way to calculate the current. Okay. So again, so after I solved the equation twice, you can see I found I1 is positive 1.43 ampere, I2 is negative 1.14 ampere, I3 is positive 0.29 ampere. Okay. You can see here I1 is positive. That means this direction is correct. This current is gonna flow this way. That's correct. Okay. You can see here I3 is positive, so this current will be this way. Okay, which is correct. This one here is negative. That means I assumed that this current should be flow this way, but in reality it will be this way. Okay, so if you look at this node, you can see I1 is enter, I2 out, and I3 are out. You get what I'm saying? And if you add them, you will find still Kirchhoff current law is true. If you add them, if you add here, you have here I1 is equal to I2 plus I3. For sure, if you ignore this negative, because negative means only direction. Okay, so if you add this one plus this one, you get I1. So actually, what happens I1 is coming this way, and then it's gonna split. Some current is gonna flow this way, some current is gonna move this way. Any questions? Yeah, sure.
So the I1, I2, and I3, in the example, we're given directions to us, rather than just us assigning them. Is that the way to look on a quiz or something? Will you give us the directions of the currents, or will we have to decide for ourselves which way to assign them?
Yes. So, and if I give you the direction, you have to use the direction given to you. If I don't give you the direction, you have to assume the direction. You have to choose the direction. That's why I'm asking you when you go home, okay? Instead of selecting this direction, you can change them and solve it and see if you will get the same results or not.
Okay.
You got what I'm saying? So here, this is just a choice. So if I give you something like that, you need to choose. I'm gonna assume I1 is moving this way, I2 this way, I3 this way. Okay, you can make any selection. It does not matter because at the end it will be shown from the side. Okay, if your direction. So here I1 is positive. So yes, it's gonna be this way. This one, this I2 actually is gonna it's the same number, 1.14 ampere, but it's gonna be this way, not the way I selected. You got what I'm saying? Okay, so now, so again, what I want to do in this example, guys, I want to calculate the current everywhere, also the voltage everywhere. So now I was able to calculate the current here, I1. I was able to calculate the current here, which I2. I was able to calculate the current here, which is I3. So what I need to calculate here? I need to calculate the voltage here, also the voltage here, and also the voltage here. Okay. So, and this is very easy, just Ohm's law. So if you know the current, you can multiply it by the resistance to get the voltage. If I already get the current here, that's why the most important part here is to find the current in every branch. Once I find the current, I'm gonna multiply by 8 to give you the voltage. Same thing for this one here as well. Okay. So yeah, that's what I'm explaining here. On top of that, so here, yeah, I calculate I times R, I got the voltage. Okay. Now, if you want to also study the power, so actually what happens here, the amount of power here, okay, consumed here, amount of power consumed here, amount of power consumed here should equal to the amount of power consumed or generated by these two. Okay. So here, that's why here, if you wanna extend your analysis to the power, again, once you have V and I, okay, the power is very easy. You just multiply I times V, okay, for power. So I calculated here, so this element, which is this one here, is receiving this amount of power. I just multiplied I times V. Same thing for this one here, I times V, okay, this amount of power. Also, I can calculate the power here, I times V. Okay. Any questions? Okay. So now I'm gonna teach something voltage divider. Okay. So let's explain the main idea here. Okay. If you have, let me go to maybe I want to explain it in PowerPoint in much later. Okay. Look here, guys. So for example, if I have a battery this way, and then I have a resistor this way, and then a resistor this way, okay? This is R1, and this one is R2, okay? And then, this point, I'm gonna call it A, and this point is called B, I'm gonna call it B, okay? So, as you see here, VAB equal, for example, if the battery 5 volts, so equal 5 volts, because the difference between this point and this point here from the battery is 5 volts, okay? But as I told you, because this is one node, if the voltage here is VB here, and this one is VA, okay? So this one also VB, this one is VB, because this is the same node, okay? It's a wire, and the wire there is no voltage drop, it's the same voltage, okay? That means the voltage here also is VB, all of this just one node. It's the same, 1 point, okay? So that means this voltage drop 5 is gonna be the same like here. This is A and B. So this also will be 5. Okay, so this one is 5 and this one is actually 5. Okay. So what happens here is I have here voltage drop here. I'm gonna call it V1 and I have V2. So this 5 volt is gonna be divided between V1 and V2. Divided. Okay. So the summation V1 plus V2 should equal to the 5 volt. That okay? By the way, and maybe some of you a little bit confused about this part. So here, if I have a battery this way, I have a resistance this way and resistance this way, I can redraw this circuit in exactly same circuit, but I'm gonna redraw it. Look how I'm gonna do it. So here, this one will be this way. We have here R1, R2, and then R1 and R2. So these two circuits are the same. I didn't do anything, I didn't change anything, it's exactly the same thing, but I just redraw it. Okay. As you can see here, the same current here will be the same current here, no change. I just redraw it, okay? Because again, this is just one wire. If you make it small, it's make it bigger, it doesn't matter, just one node, one wire. Anyway, but the reason I want to do this way, because if you have some information about parallel, okay, you can see these two here are parallel to the battery here, okay? Because if this node is A, this node is B, so the voltage here drop here. If it's this one, for example, 5 volts, so it has to be also here to be 5 volts because they are parallel. Okay, it's the same point. So here we have point A and point B. The difference between A and B is 5. The battery told me. So also the difference between here and here also the difference is 5. So now I know the total difference from here to here is 5. Okay, but this 5 is gonna be divided. This one is gonna take some value. This one is gonna take other. For example, if this one is 2, this one has to be 3. If this one is 2.5, 2.5. So I'm gonna divide this voltage across these resistors. Is that okay? So how we divide it? Okay, it's very simple. So I'm gonna prove it. The way we can divide it is, for example, if you have R1 this way, and you have here R2, and you already know the difference here. For example, I'm gonna call it V. Okay, so this one V1, this one is V2. So there is a law. This law we can just use it, but you need to know it, and also I'm gonna explain how we calculate it this way. Okay, but if you have a situation like this one, you should understand the voltage drop here from this here to here is gonna be divided between these two. That means V should equal V1 plus V2. Yes. Okay. But here is gonna be divided what ratio? What ratio? Okay, I'm gonna tell you what is the ratio. So actually, and in the slides I will choose. You have very simple proof. Okay, but the ratio is V1 equal the voltage drop across V1 is actually R1 divided by R1 plus R2. So the ratio of R1 for the summation, R1 divided by R2 times V. So this is the ratio. What about V2? V2 should equal R2 divided by R1 plus R2 V. Is that okay? How? I'm going to tell you about the proof. Okay? But this is like a law. I can just use it. Okay? So I know the voltage drop from here to here is V, and then I'm gonna divide it. This is called the voltage divider. Okay, divide it. But I'm gonna divide it based on what ratio? The ratio is this one R1 divided by the summation. This one R2 divided by the summation. Okay. So there are several interesting things here. The first interesting thing is if R1 is equal to R2, if the two resistors are equal. Okay, so this ratio becomes half and half. So that means every resistance is gonna take half of the voltage. Is that okay? If they are equal. Okay. Now, if I increase one resistor, is gonna take more voltage than the other one. You get what I'm saying? That's why if you have here two resistors, the bigger resistance is gonna take more voltage than the other one. That okay? If they are equal, so in this case it's gonna be half here and half here. Make sense? Yeah. So I'm gonna tell you how it's very simple. I'm gonna tell you how we calculated this one. But what you need to know for now is the law is if you have a situation like this one, you have here, I know the difference here is V, and then I have here R1 and R2. So actually V1 equal R1 divided by R1 plus R2 times V. Okay, same thing, V2 should equal R1 divided by R1 plus R2 V. And also you should know V1 plus V2 is equal to V, because I just split the voltage between these two resistors. Okay, and this resistor has to be series, not parallel. Should be series, as you see. Okay.
And formula for V2 should be R2, is that correct? Instead of R1?
Yeah, I'm sorry. You're right. So yeah, so here the resistance of this one over the summation. The resistance of this one, you are right. I'm sorry. Is that okay? And then you can notice, as I said, if they are equal, so it's going to be half and half. If you make one bigger than the other, it's going to take more voltage. Okay. If one of them is too big and one is too small, so almost all V is here. You know what I'm saying? So this one very, very, very small. This one is too much bigger than this one. You can assume most of the voltage will be here. And this one is going to take very little voltage, like 0.01 something, I can ignore. You understand what I'm saying? For sure, if this is a very small resistor. Any questions? One more thing. We can actually, okay, so here I explain it in case if we have two resistors. What if we have 3 resistors, 4 resistors? But again, they have to be series. So they have to be series this way. Yes, this one also applicable in case of you have, I can generalize it. That's what I'm doing right now. So for example, if you have here R1, and then you have here R2, all the way until you have here, for example, Rn. And then you here voltage drop V. So again, we're gonna split this voltage across them. Okay? They are not gonna be, they can be equal, they may not be equal. The drop here, when I divide it, can be equal or not. It depends on the values of the resistance. Still, V1 equal equal V1 plus V2 all the way until Vn. Yes. Okay? Because I just split, I divide the voltage between them. But what is the formula now? Yeah, very easy. It's the same, almost the same formula. So V1 equal R1 divided by R1 plus R2 all the way until Rn. So you have to add everything together. So still ratio times V. Yes. So here the ratio is this resistance over the total. Give you the ratio of the voltage that will be here. Okay. So in general, for any V here, Vi should equal Ri divided by R1 plus R2 all the way until Rn times V. Okay. Where I can be any number. Any questions? Look here, guys. Usually, in my experience, usually students make mistakes when I explain something and then they apply it for something else, for a different case. You got what I'm saying? So here I'm very clear if you have series resistors this way. Okay? But if the circuit is different and you have other resistor here, you cannot apply it this way. Okay? So it has to be in this specific case. So let's see here. So that's what we call voltage divider. So the conclusion, as I told you here, once you have this V, is going to be divided between these two. So actually, yeah, this is the formula. V1 equal R1 divided by R1 plus R2 times V. Same thing for V2 here. Okay. So how you came up with this? Very simple. So the proof for this one is, as you see here, the current here, as I told you, V should equal V1 plus V2. So this voltage should equal the voltage here plus this voltage. Okay. This voltage V1 equal I times R1 This one is because it's the same I, it's the same I. So this one should be I times R2, as you see here. Okay. And by this way, I is actually V divided by R1 plus R2. Okay. Then after that, V1 is R1 times I. I just take this one, multiply it. That's it. Okay. So again, what I did is I started from V equal V1 plus V2. V1 is actually I times R1. V2 I times R2 is the same I. So the same I here is the same I here. Okay. And then from here, I can calculate I, which is equal V divided by the summation, by the total. And then, if I multiply this one by R1, I get V1. If I multiply I by V2, I get R2. Okay? Very easy proof. Okay? It's the same thing here. It's exactly the same thing here. So V is equal V1 plus V2 plus V3. It's almost the same proof. Okay? And then we can have, and then we're gonna have the same formula for any number. So you can use it the same way. I can get almost the same formula for any number of resistors. So here I give you just for 2, but you can generalize it for more than 2. If it is more than 2, so the voltage at N, at resistor N, equal Rn divided by the total times V. Vs is a resistance of the battery. Any questions? This one is called voltage divider. You can take from the English name. You have a voltage and then you split or you divide the voltage across several resistors. Okay, I have a total V. This resistance is going to take a part of it. So this is going to take a part of it. Another resistance is going to take a part of V, so that the total is equal to V. I split the voltage across multiple resistors. Is that okay? And they have to be series. The second law also, which is also one important law, is current divider. Now I want to divide the current. Okay. In this case, this resistor has to be in parallel, not series, because if they are series, it should be the same current in parallel. So here, again, if the resistors are series, so the current here is the same current here. We don't split the current, it's the same current. We divide the voltage. Okay? But the other case here, if you have a current source this way, okay, and then if you have two resistors this way and you have a current I here, if you have current I, and then I'm gonna get here I1 here, I2 here, we have R1, we have R2. Okay, so we're gonna split. So it's the same. So we know already from Kirchhoff current law, this current is gonna be split between I1 and I2. So here I should equal to I1 plus I2. Kirchhoff current law. We split the current. So now the question, similar to what I did in the voltage. Now, what is the ratio? So now we know that this current is gonna be split. But when I split it, is that 50%, 50%, 70%, 30%, or what ratio? Okay, who's gonna determine the ratio? The resistors. The resistor is gonna determine the ratio. Okay, there is something very interesting here, guys. I want to make comparison with before. Think about it. Here, in case of the voltage, the big resistance, if R1 is bigger resistance, is gonna take bigger share, bigger ratio of V. So the bigger resistance is gonna take more voltage or bigger voltage. Okay. You can even think about it in a very simple way. We know the current here is equal to the current here. And the voltage is I times R. So when you increase R, the voltage has to increase compared to the other one because it's the same current. Okay. Here, I want to make a comparison. Here is going to be the opposite. Okay. What do you mean by the opposite? This current is going to flow, more current is going to flow in the smaller resistance. Okay. So, because it's going to face less resistance. So the current will go through, I have two paths. One path, I receive too much resistance. The other one, I receive little resistance. So it's going to go more current, it's going to go to the low resistance. Okay. So it's the same thing as you will see Number one, if R1 equal to R2, if the same current, so this I is gonna be divided in half. Okay, I'm gonna give you the exact ratio, but just I want you to think first by intuition. Okay, so if it's the same resistance, so this I is gonna be half of I here and half of I here. Okay, and then when I make this resistance smaller, so I'm gonna attract more current. Okay, I can give you also another reason because I just want to connect too many things together. So I can give you another reason. Look here, guys. These two resistors are in parallel. In parallel, these two resistors. Okay, in parallel. Parallel means this is one node. So this is node A, this is node B. That means the voltage across them, they have the same voltage. The same voltage. Okay. Remember when in case of when they were here, it was the same current. The same current. Now current is different when I connect it in parallel this way. Current is going to be different, but it's the same voltage. You got what I'm saying? So I just want to give you another way to think about it. Okay. I don't want to just give you equation and this is the equation. No, we also need to have some intuition or think about it. Okay. So look what I want to say here. So we agree, both of them have the same voltage. So here, the voltage here, V, and the voltage here, V. They have the same voltage. Okay? So V should equal I1 times R1. Okay? Also equal I2 times R2. Okay? We have here in this resistance R1, we have Y1, we have here I1. Here we have R2, so we have I2. You know the voltage is I times R. So that means I1 times R1, okay? I2 times R2. So what I want to say here, they are constants, the same like the same voltage. Okay, so what you want to say here? What I want to say is when this resistance is small, I have to increase the current to get the same value of V. You got what I'm saying? To have the same V, that's why I just want to give you another way to think about it. To have the same V, that means when the resistance is small, I have to increase the current, okay? So that when you multiply, you are gonna get the same voltage. I'm gonna give you the exact formula, or the exact formula is also, I also want to prove it, but for now, the exact formula is, look here, I1 equal, okay, what ratio of I? What ratio? So I need to get the ratio. The ratio here is going to be here R1 plus R2, similar to the voltage. But the difference is, so it's going to be R2 here instead of R1. So here's the current I1 equal R2. Remember, in case of voltage, it was R1. No, now here it's going to be R2 divided by the summation. Same thing here, I2 equal R1 divided by R1 plus R2I. Okay, so again, the current in this branch equal the ratio, which is the resistance of the other branch divided by the summation. Okay, so you can again, this is what we call current divider, or this current is going to be divided with this ratio. Okay, you can see if R1 is equal to R2, so it's going to be, this ratio is going to be half and half. That's what you can see. Okay. So I'm going to choose the proof for this one. Yeah. So here, as I told you, I should equal I1 plus I2. So the current here is I is going to split between I1 and I2. Okay. This is the first one. This is Kirchhoff current law. The second one here, voltage. The Ohm's law. I told you here the voltage here is called VAB. So the voltage here is equal to the voltage here. So I1 times R1, okay, which is equal V1 here, is equal to V2 because they are parallel. Okay. Again, guys, please listen to me. From my experience, I did something and then student applied for something different. Okay. So I'm very specific. If you have this case, you can apply it this way. Okay. But what if there is a resistance here? No. So it may be, or there is some in a different way. Okay. There is something different. It's not exactly like this one. Okay. It may not. And you just take it and apply it in this case. You understand this? I see a lot of mistakes like this one. Okay. So you need to understand here. I have to use this one when I have something exactly like this one. Okay. Anyway, so and now, so here I have here I equal I1 plus I2. Okay. So here I can split I2 here, I2 yeah, from this part here, I2, I wanna get I2 in relation of I1. Okay, so here you can tell here I2 is equal to R1 divided by R2 times I1. That's what I did here. Okay, and then you can add everything together as you see here, and then you get the formula. The formula I have just explained. So and then so I is equal this value here, or I1 equal this one here. I just want to show you how I proved it. So the conclusion, okay, you don't need to prove it. You can use it like a law. So once you find something like that, you can just use it. Okay. So the conclusion is, if you have something like that here, if you have a configuration like this one here, I can simply say I1 here is equal R2, the second R, divided by the summation of the two R's, okay, times R. Okay. Again, I just want to bring to your attention, this one is different from what we had here. What we had here is the voltage here is R1, not the other one, R1 divided by the summation times V. You got what I'm saying? So pay attention to this one. Okay. Same thing here. I here is the other resistance divided by the summation of the two, okay, times the total I. And again, the summation of I1 plus I2 is equal to I, because this one current divider. So we're going to divide the current between these two branches. Any questions? Okay, so now I'm gonna come to when we connect resistors, we can connect resistors in one of two ways. Okay, so we can connect the resistor in series, or we can connect the resistor in parallel. Okay, you may be familiar with them, but I need to teach them. Okay, so if you connect the resistor, for example, if I have here resistor here R1, and then I have here R2, and then I have here R3, for example, I have R4, and then I have a battery this one. So you can see when the current flow is going to be the same current coming this way. So the current is going to flow through R1, it's the same current like R2, it's the same current like R3, it's the same current like R4. Okay, so in this case, we say R1, R2, R3, R4 are connected in series. Okay, and by this way, I can calculate what we call the equivalent resistance. Equivalent. So I can say the equivalent resistance equal to R1 plus R2 plus R3 plus R4. Okay, what this means? It means this circuit, it is something like that. You have here resistor, you have here battery, and you have equivalent resistance, and then you have, and the current here is going to be the same current like this one. This is I, and this is I. Okay, the same current. So now I can calculate the equivalent resistance. Okay. By the way, you know, we do it all the time. Sometimes in labs, in your lab or in capstone, for example, I need, for example, 3K resistor, but I don't have, I need 3K resistor, but I don't have 3K resistor, but I have, so what you can do, you can connect 1K and 1K and 1K. By this way, what in series, so if you connect them in series, so by this way, you are able to have one resistor, it's like one resistor with 3K ohms. You got what I'm saying? Any questions? Okay. So now, also, This resistor, I can connect them in parallel. So you should understand what is the difference between or how it is different, okay? So as I told you, in case of series, the current, I always, if I'm confused, is it series or not series, okay? Sometimes it's not parallel, it's not series. So it depends on, it's not all the time, it's not like all the time it has to be series or parallel. But anyway, so I think this is the key to remove any confusion. In my opinion, the best way to understand. In case of series, the current here is the same, like the current here, the current here, the current here. So it's the same current, but this voltage is gonna be divided here. So V1 plus V2 plus V3 plus V4 equal to ZV. So it's the same current, but we divide the voltage. Okay. So this is series. In case of parallel, what happened here, look here, guys. So yeah, so here, so they have, so here is this terminal of the resistance, this terminal of resistance, they have to be connected together. Okay. So what happens here is, for example, if you have a source here, so the current here, the current is divided I1 and I2. Is that okay? But the voltage is the same. So you can see the voltage here across this voltage are the same, but the current is divided here, in case of the series, current is the same, but voltage is divided. Okay. How can you know if it is parallel or not? Very simple. They should have the same node as you see here. So and here is the same node. Otherwise, if it's not the same node, it's not going to be the same voltage. So if this is A and B, so that should have voltage here is equal to the voltage here. And to make the voltage here equal to the voltage here, it has to be the same node. Okay? So this node A, node B. Okay, so also I can if this one R1 and this one is R2, okay, same way I can make equivalent resistance, the equivalent resistance, okay. The equivalent resistance here in this case is actually we calculate it this way. So this one I can say this one this circuit here is actually we have equivalent resistance here, like you have only one resistance, equivalent resistance, and the current here I. The current here I, okay? The voltage here is V, the voltage here also is V. So it's almost the same, this circuit is similar to this circuit, okay? But how do you calculate this equivalent resistance? The formula is 1 over the equivalent, this equivalent case of parallel, equal to 1 over R1 plus 1 over R2. So if you calculate in case of two resistors, this one should equal to R1, R2, R1 plus R2. Okay, so the equivalent is R1 plus R2 divided by R1 times R2. Sorry, this is 1 over the equivalent. In other words, if you need to flip it, so the equivalent is R1 times R2 divided by R1 plus R2. Okay. Also, sometimes in labs, for example, if you have 1K and you have here 1K, you connect them in parallel. So this one will be equivalent to a resistor that is half K ohm. Okay. So sometimes in labs, I'm looking for a resistor that is half K ohm. But I don't have this resistor. Okay, you can make it from 1K ohm. How? You connect 1K and 1K in parallel, so this will act similar like half K ohm based on this formula here. Okay. This formula, by the way, is general for any number of resistor. Okay. But this one, this formula here is only with the R2. So in other words, if you have here R1, R2, R3, so 1 over R equivalent equal to 1 over R1 plus 1 over R2 plus 1 over R3. And then you can calculate it. Okay. But in case of two resistors, yeah, it's the same formula, but you can calculate this one. Any questions? Again, you may find some difficulty to understand when you see, I have several examples, but you may find some difficulty in order to see these two resistors are series or parallel. But if you think the way I told you about it, if it is the same current flowing in the resistor, so it is series. Okay? If the current is split between them and they have the same voltage, it is parallel. So parallel means same voltage, but the total current is split. Okay? Series means it's the same current, but voltage is split. Okay? So anyway. So this is the first one. So here, this one series. So this is the equivalent. So this one is equivalent to this one. What do you mean by equivalent? It means if you calculate the current here, it will be the same current here. Okay? But and this voltage here is split. So V1 plus V2 plus V3 equal to V. And it's the same current here. Okay? But the voltage drop here is actually I times R equal to V. Okay? And this R actually is R1 plus R2 plus R3. Okay? So in general, this is general formula for any number. So just add R1 plus R2 plus R3 for any number. Okay? This one for parallel, in case of parallel. So these three are parallel, these three here. Okay? Why? Because they share this terminal is connected together, it's the same node. This terminal also connected together, it's the same node. And the voltage here is similar to the voltage here, it's similar to voltage here. But the current is gonna split between them. But the same voltage. Okay? So anyway, so I can replace these resistors by one resistor here. And once I do that, the current will be similar to the current here. The voltage will be the same like the voltage. Okay? Anyway, so how can you do that? I told you 1 over, so in general, this is the general formula. 1 over R equivalent or R parallel is actually 1 over R1 plus 1 over R2 plus 1 over R3 and so on. And in case of 2, if it is only 2 resistors, so actually multiplication R1 times R2 divided by R1 plus R2. Okay? Here I'm telling you how I was able to calculate it. It's very easy. Look here. The current is split. So here this I equal to I1 plus I2 plus I3, as you see here. Okay? I1 is the voltage V divided by R1. I2 is voltage V2 divided by R2. Sorry, V2 or V1 is the same, right? I'm gonna call it only V because they are parallel. Here also V divided by R3. Okay, so I can take V here is common, so I can take it here. So R should equal 1 over R1 plus 1 over R2 plus 1 over R3, all of that times V. So I can just take this one here, I'm gonna call it 1 over R parallel, because I equal V divided by R. I equal V divided by R. So I can say this is equivalent to 1 resistor, 1 over R parallel. Anyway, any questions? Okay, so now I have several examples. I can give you some resistors, and then I'm going to ask you to calculate the total or the equivalent resistance. What is the equivalent resistance? All what we are going to do is series. If they are series, you add the 2 resistors. If they are parallel, 1 over R equivalent equal 1 over R1 plus 1 over R2. Okay. So, for example, let's look at this example here. If you have R1 and R2 this way, and then I want to look this way, I want to look from here. Okay, so what is the resistance going to be seen from here? If you have a voltage source here, if you have a voltage source, what is the total resistance that's going to be seen by the voltage source that is here? Okay, this is very easy case because you can tell here this R1 and the R2 they are parallel. That's very easy because they share the same terminal here. Okay. So in this case, I can easily calculate. I can say R1 parallel R2, okay, which is actually R1 times R2 divided by R1 plus R2, which is equal to 2.4 ohms. Okay, so here I give you R1, I give you R2. So the total, so this one is equivalent to one resistor, or the total resistance that's gonna be seen by any source you put here is actually 2.4 ohms. This is very easy case. Okay. Now let's see something like this one. Okay. Look how can you calculate it again. Look what happens here. The current is gonna come this way, and then this current is gonna split between these two, and then come back here. Okay. So how can we calculate the total resistance this way? So let's see if I can explain here. Look, so I have here, guys, I have resistance here. I'm gonna call it R1, and then I have here R2, and then we have here R3. I want to calculate what resistance you are gonna see from here. If you have a source here, what resistance is gonna see, or total resistance that can you see from here? Okay, look here. So what happens is that the current is gonna come here, and then it's gonna split between these two. It's very obvious that these two resistance are parallel. Okay, so I can say this one is equal to, I have here R1, and then I'm gonna have here another resistance equivalent to these two resistors, because these two are in parallel, which is R2 times R3 divided by R2 plus R3. So these two resistors are in. So I'm not gonna do it in one step. So I am gonna do it in several steps. The first step, there is no doubt these two are parallel because they have the same voltage and the current is split. Okay. So I can replace this one here. I can replace it by the equivalent resistance this one. Okay. And then now the same current. So I'm gonna consider this one by the as only one resistance equivalent this one. Now R1 is series with this current because the same current is gonna go through it. So by this way, R equivalent equal to R1 plus the other resistance here, which is R2 times R3 divided by R2 plus R3. Any difficulty here? By the way, I can redraw this circuit so that I'm gonna make it like it's gonna be more clear how the relation between them. Okay, let me make it more clear. Okay. Again, I'm not gonna do anything, I'm gonna redraw it. So it's the same circuit, I can redraw it this way. I have R1, and then the current is gonna split between R2 and R3, and then it's gonna be come to here. By the way, I didn't do anything, they are identical. They are the same thing. I just redraw it. Okay? So here the current is gonna come here, it's gonna split between these two. Okay, and then after the split, it's the same current. This is I, so it's gonna be the same I come here. But after it is split. So it's the same thing like this one. Here you have I, it's gonna split and then come I here. Okay. So if you but maybe this is easier to understand the relation between them. Maybe this is easier, I don't know, but anyway. So here it's very clear R2 and R3 are parallel, so this is parallel, and they are series with R1. Okay, why? Because current here is the same will be the total current is gonna go through this one. Okay, any questions? Let's give you more examples to just it's I think examples are very important. Yeah, so that's what I did. Here you calculate this one, you get the total. Okay, let's for example look at this here, this example here. You have a current I here, okay, and then you have these two here, and then you have these three here. You know how it works? Look here. This current is gonna come here, split, and then the same current will come to here. So this is IS, it's gonna split, and then IS is here. Okay, and then IS is gonna split, and then come back to here, come here again. So there is no doubt these two are parallel because you can see here it's the same voltage, the same point. This point is similar to this point, so I can calculate the equivalent to this one. It's going to be something like this one. Same thing. These three are parallel. Okay, so they are equivalent to one resistance. Okay, you have the formula. I don't need to repeat it again. You have the formula that can help you to calculate the equivalent resistance to these two, and also the equivalent resistance for this one. Okay. Now this resistance and this resistance are series. So the voltage here is gonna split across them. It's the same current here, it's the same current here. Okay. So I can just add these two together to get the equivalent one. Okay. By the way, I can figure it out from here. Look here, guys. The current is coming this way, it's gonna split and will come here. The same current will be here. So the current here will be the same current here. So this resistor and this resistor are series to each other. The voltage here equal to the voltage across these two, which are equal. So voltage here and voltage here is the same voltage, but the total voltage is actually going to be split between these two and between these two. Any questions? Okay. So here, so once what I did here is, yeah. So here I just, the first question here, I want you to calculate the equivalent resistance. Okay. I already calculated the equivalent resistance. You have to take RB1, RB2 until you add them together. So this is the first part. This is just easy. In the second part, I wanna get the current here, and this is just very simple. This is the current division or current divider law. So you have here current IS. I give you IS in the question, I guess. Yeah, I give you IS here. So I give you the total current. So if you know the total current, can you get the current here? The current here, yeah, you already have a formula for that. Okay. So the current here is actually R2 divided by the summation. This is the ratio times IS. Okay, that's N1. So I'm gonna leave this one to use, just very easy. Same thing here, you have the total current, so you have a formula, so you can get the current here, the current here, the current here. Okay. Or here we don't have a formula for 3, but it's very simple. What you can do here, you can if you wanna, here I have I total, okay. So this is the total current I is going to be divided between 3. I think we don't have a formula for 3, it's going to be a little bit complicated for 3, but you can simply, what you can do, you can calculate equivalent for this one, equivalent for these two resistance. Okay, now you have two resistors, this one and these two together. Okay, or the other way, as I did here, you have the you have the total voltage. How can you get the total voltage from here to here? I times R equivalent. So if I multiply I times the total resistance, just give me one minute to finish this example. Okay. So what I'm seeing here, guys, is I already know IS, it's given to me. Okay. So if I multiply IS by this R equivalent here, I can give the voltage drop. Okay, which is V1 or V2. Okay, if I divide V1 by R1, I'm gonna get I1. If I divide V2, which is equal to V1, okay, how I can get this voltage? Simply multiply I by this R. Okay, give you the voltage. This is one way to calculate. There is another way. Current divider. Okay, so you can do current divider. You have the total here and you have two resistors. Okay, same thing you can do here. If I multiply I times the equivalent resistance, I'm gonna get the voltage across these three resistors. If I know, so V3 equal to V4 equal to V5, they equal IS times RR equivalent here. Once you know the voltage, divided by the resistance, you can get this current. Divided by this resistance, you can get this current. Divided by this resistance, you can get this current. This is another way, one way to do it. The other way, you can also find some way to apply the current divider. Okay, I think that's enough for today.